So, hello. Twitch sets talk. Yes, I did set the talk, so that's okay. What do I say? Oh yes, I should. Yeah, just give me a moment. I'm gonna share it on the Zig Discord, so maybe somebody is going to watch it. Okay. Yes. Okay. Evo, na C++. Včeras.
Imaš ovdje jedno mjesto.
Okay. So, welcome everybody. It's a full. It's a full. I didn't expect so many people, so that's cool. Just before we start, I want to say a few things. So, I'm running on a really old laptop. It's like 6+ years old. So, and I'm streaming at the moment. You can. It's on Twitch. Twitch.tv/notke if you want to send it to somebody or something. Yeah, we don't have to watch. Whoops, I didn't want to do that, but whatever. Okay, so yeah, I wanted to do some slides, but then I decided, it's much faster to me to just give a live demo because that's like you can very easily do that with Zig. So yeah, let's see. And also, like, I just wrote the whole thing in this text file. So yeah, very like lo-fi slides. Okay, so I'm not. I'm gonna try to cover like most of the things in Zig. But I'm not gonna talk about multi-threading because I don't know much about it. I haven't really done much. I know that some stuff in Zig, like async await, is under construction still in Zig. So, but we will talk about that later. Okay, just to know that, and there's going to be some details like C interrupt, which I'm not going to go into too much detail because it's very specific. Okay, so yeah, first off, who am I? I'm Ivan. I just want to say a little bit of background so that you know why I want to use Zig, why I like Zig. So I've been an indie game dev for 10 plus years. I actually studied architecture, so completely not didn't go to programming school, but I started by like modding games that existed back in the day, like 15 years ago. And because I knew 3D modeling from architecture, but I was really like I really wanted to make my own games. And then I discovered Unity, and then basically I started coding in C#, and I've been coding in C# since 2013, still use it almost every day. But then, yes, and I've done many game jams. You can find some of my games that I did on notke.itch.io. over here. On most of them are game jams. Some are like long-term projects, and but in Unity I found that there was too many limitations. So like especially because I was really interested in procedural generation and then making like meshes at runtime and stuff, and C# gets really slow in that. So in 2020, when the pandemic started, I started learning C++, mostly because I was challenged by a friend of mine. He was like, yeah, if you really want to avoid all these limitations, why don't you write your own engine? And I was like, are you crazy? I'm not gonna write my own engine. But then I just tried, and of course there was so many stumbling blocks when learning C++. I mean, it's but over time you get better at it, and yeah, like you just kind of start understanding. And then I never intended to use the engine for a game. It was just like a toy thing, just C++, like, okay. But then suddenly I was like, okay, I put a little car and I was driving it, and I was like, okay, I can actually make a game with it. So right now I'm actually making Shakedown Rally, which is this game over here, and it's like a lo-fi pixel art PS1 style rally game. This is actually an old this is all old screenshots, so it actually looks a bit better now. Okay, so yes, and then in the meantime I heard of Zig a few years ago, maybe 3 years ago, and from time to time I would hear something about it, like, oh yeah, it is good, it is like, but it was not very convincing until, like, it was really hard to get the point of Zig, like, why is Zig so good? Because I only heard some things and I was like, I'm not gonna shift my whole thing to Zig. But then it was like a long process of like hearing about more and more things, and I was like, wow, this is actually super cool. So yeah, and then I kind of tried to make an engine to see how difficult. Well, what is this? I didn't finish the sentence. But I tried to make a Zig, an engine in Zig that is kind of inspired by my C++ engine, and but I did it only for like 2 weeks, and I already got something to render. But then I had to go back to doing other stuff, so I never. But in the future, I intend to use it for an engine. And yeah, I often stream game dev on Twitch, so you can find me on this link. And unfortunately, I'm a Windows user my whole life. I know that people in the Decentrala here are like, whoa. But games, I'm sorry. Like, what can I do? It's like you make games on Windows. I wish I was not the Windows the user. That was Freudian slip. Okay. So let's go next. So Zig. Let's finally begin with Zig. So Zig is kind of hard to put in an elevator pitch. I already said that there's a lot of things that you need to find out that you will like, oh, this actually is pretty cool. But over time I fell in love with the language and community, and yeah, if you follow the link, this is like the main page, and the coolest thing that I want to show in this room is, like, it says the Zig community is decentralized because we're in Decentrala now, and so yeah. But basically that's also their motto. Like, they don't want to have any kind of official thing, and we're gonna see also with the package manager, like, they don't have a main like repository of things. You can just download anything or just link and yeah, anyway. Okay, so Zig is really kind of hard to explain, so I don't know exactly where to start, so let's I don't know, I'll just try. Okay, so a few facts. This is literally like copied from Wikipedia. Zig is an imperative, structured, general purpose, statically typed, compiled systems programming language. And I remember that when I was announcing my Zig talk on Decentrala, somebody said, like, I know some of these words. So yeah, So let's go through what does it mean? Like imperative, it means like you have to direct your commands, like do this, put this thing in the memory, do this. Unlike declarative languages like I don't know, HTML, you just put your HTML and it's like you expect it to be drawn from, it's not like giving commands. Structure, that just means that it has a like a if-else control flow with scopes. General purpose means that you can do anything with it. It's not meant for something very specific. Statically typed, it means that it has a strong type system. So a number is an int is an int, a float is a float, and it's checked at compile time. And compile, it means that it compiles into a binary for a target machine. And systems, that's kind of like you can make operating systems in it. I don't know. I never really understood what systems programming means, but you can make binary programs, I guess, with it. Okay. So a little bit of history. It was started by Andrew Kelly, I have to say, because I mean there's multiple people now working since then, and I mean this is his site, but I'm not gonna go into the details because anyway, the first version came out in 2016. Currently the dev version is 0.14 and well 0.13 is stable. That is the one I'm using, and the reason why I'm using right now, well, usually I'm on the dev version, but there were some bugs with the Zig language server, so I had to like revert for this talk, just to make sure that everything works. Okay, so since 0.10 it's self-hosted, which means that the compiler is now written in Zig as well, so it's not using another language for compiling. Okay, and since 2020 there is the Zig Software Foundation, which is basically like they're basically working on donations. That's what it means. And there is a couple of people who are already, they're a non-profit organization and working on I wanted to say only for the reason why I put this link for Andrew Kelly. That's the guy. It's really cool. And I just wanted to say, where was this thing? Yes. So he left Twitter and Reddit because of the enshittification of internet, as he says. So it's a pretty cool read. So I think everybody should read it. And I admire his how would I say? I don't know, his position, whatever. Okay, so yes, with that. So what is the goal of Zig? Well, you can say that the goal is to be better C, because it's kind of like that was the original goal. It's like, okay, C is a pretty good language, you can do everything in it, but there's so many ways that you can shoot yourself in the foot, and let's clean that up. Let's remove all this stuff that you can like easily shoot yourself in the foot. Well, it is simple, it is explicit, it is clear, it's readable, which is very cool, because when you open like C++ standard library, you're like, what the hell is this? You open a Zig standard library, you can read everything. Okay, but yeah, this is kind of basically one thing, because if you have a simple language, it's also very readable and it's also very easy to understand. And when you have things which are like explicit, it's also very it's very easy to reason about. That's the term I was trying to look for. And then maintainability comes from that, but you can gradually, for example, I'm gonna talk about it later, but let's just go through this quickly. Robust, it has same defaults, unlike almost every other programming language. Fast runtime and compile, so no hidden allocations. The mantra is to write everything in Zig, so there's no, basically, I'll show you that later. Minimal dependencies, no undefined behavior in debug or safe mode. That is the goal. Unambiguous context-free syntax. So you know how like in C, C++ we have this is the most vexing parse is the term. I can't remember. It's like where if you try to declare, like you don't know if it's a function or it's so the compiler needs to go like, okay, it needs to look into the context, like where are you using this, and it's very, because of this it makes also the compiler very slow. So in Zig there is no such thing. It's like everything is clear what it is. Okay, so some of the really cool bits, apart from all things that I've mentioned, it's not only a language, it's also a toolchain. So it's like it has, and it's all in one. So you download this one package and you unpack it, or whatever you install it in with VS Code or on Linux. You can just do it with a package manager, and you basically have everything. You have a build system. You have you can cross compile from every system to every system. So if you're on Windows, you can compile for Linux. You can compile for Mac. From Mac you can compile to Linux. It can include and seamlessly interoperate with the C code. This is one of the like crucial bits why it's actually useful. Because if it didn't do this, it's like what rewrite everything in Zig? No, you can just include C code and you can use it. It has incredibly powerful comptime. It has an integrated build system, as I mentioned. It's part of the toolchain. No hidden allocations, is easy to read, is about memory. It has an amazing standard library, as I said, which is completely comprehensible. It has a decentralized package manager. I talked about a little bit, but I will talk later. ZLS is the Zig language server that can really help you code a lot better. It disambiguates C pointers. I'm going to talk about that as well. I'm going to talk about all these things later. I'm not going to say that anymore. It doesn't have exceptions, but it has error types. It has no header files. This is my favorite because like I don't know, writing your engine and it's just like, oh, what am I supposed to do? Like where do I? Yeah, just the
constant.
Yeah, like architecting the code in C++ is like, it takes so much energy from me, and in Zig you just don't have to think about it. It has bit packing types. I'm going to talk about later as well. It has SIMD vectors built into the language. No function or operator overloads. This is kind of like a bit contentious when you hear it for the first time, but actually it makes everything much simpler. It has strong formatting convention. This is also something that people kind of hate, but it's actually a great thing because you can read everybody's code. Nobody has their own style, basically. I call it OOP Lite because it's not really object-oriented, but it has namespace functions, as they call it. You will see later. No macros, but you have, there are ways how you can because you just use constant variables, and that's basically like macros. It has a compile time metaprogramming which completely replaces macros. And I say that here, if it looks like a function, it's a function. Fields are just fields. That's meant for clarity. And for no operator overload. So nothing. You don't have anything that is like, you don't have like properties like in C#, which like fields that can act like functions, or because like in C++ like a plus can be anything. No, a plus is just adding numbers. That's what plus is in Zig. Okay, so toolchain. But very important to say this in advance, that it's like all in one. As I said, it's like you just download it and you can just Zig whatever. You can just cross compile from any system to any system. Compile C and C++. This is the best thing because you can use the Zig build to actually compile C++. And it's like you can also use it just as a compiler because it basically packages Clang inside Zig. So you can you can compile. And the funniest thing is that it's like 150 megabytes or something. But if you download Clang, it's like gigabyte and a half or something. I don't know how they managed to like package everything in one thing. You can include C code. You can, and there's ways to like translate C to Zig with translate C. Although this can also happen automatically when you use like C include in Zig codes. But if you want to translate C to Zig, there is a program for that. You just call translate C and it will. And you can also, if you're not sure yet about like should you use Zig or should you go back to C if you're a C programmer, you can also translate Zig to C. So very fast. I already mentioned that a couple of times. Build system is also written in Zig. So there's no like CMake. You don't just like you have a build script which is also written in Zig. It has integrated tests, which is like you just create a test in a file and you call Zig build test and it will run all the tests. So it has 4 compiler modes basically, which is like in C, C++ you have the O2, O3. Here you have like debug, you have safe, fast, and small. So debug is like, while you're debugging, this is the fastest compile time, and especially in the future is going to be even faster. I'm going to talk about it later. But safe is like basically you handle all the errors, so it will panic for every error. Fast means basically like strip all the errors, and optimize it as much as possible for speed. And small is like optimize for size of the binary. And its compiler is actually lazy, which means that it only compiles what you use. So it doesn't like, like if you're using a function, if there's some function that you're not using, you don't have to use it. It's not going to compile it, basically. Okay, so let's start the live demo, and I'm going to actually start from the Scratch folder. I'm gonna open a new VS Code, and well, basically, this is like, I failed to mention this, but if you want to, do I trust the authors? If you want, you can also like live code with me, but I forgot to mention that, but I guess if somebody wants. So basically to start it. Oh my god. I forgot. Wait. What is wrong with the screen? Oh, there's another screen. Shit. Let's do it from the beginning, yes. Display got what, I don't know which one. Display. Aha. No. Okay, it's this one. Yes. Good. Okay, there it is. I'm sorry about that. I wasn't listening to the fuck. Okay, wait. There is a thing like transform fit or something, fit the screen. There it is. Okay, cool. Okay, we have it. Well, yes, so far for the people on the stream, I was just basically saying what I was reading. So you didn't miss much. Okay, so I'm going to use VS Code, and so there is actually I wrote down a few ways you can install Zig, and I'm going to do it with so in VS Code you can just install the VS Code extension, the Zig extension. So just look for Zig. This is the old one. Yeah, not this one, this one, which is official from Ziglang. Don't get the virus or something because of me. Okay, so basically you install this, and then it basically gives you what? Yes. So if I open the terminal, no, not the terminal. Sorry, not the terminal. But you can go into the thing and say into the Control-Shift-P menu and just say Zig setup install Zig. So when you install the extension, it will give you an option to install. And when you click on it, it will be like, okay, what version do you want? Do you want an idly version, which is the dev version? So I installed the 0.13, and when you install that, it's basically going to download Zig to your computer. And then when you finish that, there's a notification that pops up. Do you want to install ZLS, the Zig language server? And yes, absolutely, install ZLS. If you miss this notification, you can just also install ZLS from here. So it's like, oh wait, no, where is it? What happened? Oh, huh? Oh, there it is. Install server, right? That's the one. Okay. So yeah, and now we have an empty project. What you can do is you can just say zig init, and this will actually create the project for you. So what you get is you get a build zig, which is your build script, and it has already like all the comments of like, oh, it explains to you. It's a little bit verbose, so it explains to you how the build system works. Which is pretty cool for somebody who's starting out. But when I start making projects like 2 years later, it's a bit annoying. So the first thing I do is just delete everything, delete all the comments. But you know, it's good for you to read it if you're just starting out. Okay, and one more thing is that the zig init actually. So yeah, let me explain what is going on without the comments. Just a moment. Okay. So yeah, what we're doing here is we're just saying like, okay, what target are we targeting? What's machine? And the default one is always your system. So when you are running on Windows, it's going to compile for Windows. Optimize is basically like, do you what optimization level do you want? I was talking about those 4 optimization levels, and by default it will be debug. But you can also specify this in your arguments when you're calling zig build. And your library, yeah, so basically this example it will compile a library and it will compile an executable, which is not actually what I want. I just want the executable so that we can see it running. Okay, so let's, yeah, the arguments here is where the arguments from the build are passed. And we have the run step, which is when you call zig build run, that's going to be run. And you have tests as well, which are automatically added. But of course I'm going to, wait, there are lib tests, which I'm going to delete. And I already have an error, which is perfect. And this we don't need as well. And there it is. We should have like now exit build. Okay, let's do a zig build run. And let's see what happens, right? It's compiling. Maybe it's going to take some time. Okay, so there's also other ways to install. Yeah, of course you can just download the binary. You can also use ZVM, which is the Zig version manager. And this one, yeah, this one call like this ZVM install with ZLS and master or 0.13 or whatever you want. So that's pretty cool because Zig is not 1.0 yet, so it's like pretty unstable. So it's nice to have a tool which you can revert to different versions, and or you can on Linux, you know, on the systems that use apt, you can just use zig sudo apt install zig. Okay, so let's start with what's the language about. So did it run? Yes, it did, and it says all your code base are belong to us. I saw a complaint somewhere, like there was I think it was an issue on Zig repository, like why did you write all your code base or belong to us, because it sounds scary. Like do you own my repository? What is this? It's like a security issue. But it's just a joke, so because of the name Zig and the meme. But yeah, okay, so this thing has, yeah, we have this root zig, which is making a library, which we don't want. I'm just going to delete it. And yeah, so it has created this main with a little like print. And yeah, and there is also like an example how to do a proper buffered writer and stuff. We don't care about that right now. So I'm just going to keep the all your code bases that belong to us. And tests. So yes, Zig has tests that you can basically, okay, here is an example of like of a test where yeah, well, this is still advanced, but you're creating an array list, which is like a vector, and you try to append a number, and then it will expect equal, like is this equal, right? And then it will say successful test. Okay, but anyway, yeah, just know that tests exist, and they're built into the language, so you can call anything. Just put a test and a string. Okay, so we have the minimal example, and yeah, so basically you have a const, which is basically if it can be resolved at compile time, it basically then acts like an alias. So what you have this import, it's basically like going to be named, this thing is going to be called std. So you can so instead of like using a define in C++ or like const expr or whatever, you just use const for everything. But if in the function, the const is actually going to be a number, right? Const is actually going to be like something where you can't have like a const in C or C++, something where you can't have compile time resolved variable. You're going to have immutable variable, basically. So and there's also var, which is like which is like a mutable variable, right? So you use const and vars all the time, and by default you should always use const because that's the most efficient. And there's one more thing, because like Zig actually, as you can see here, unused local constant. Can you see? Yes. Zig doesn't allow unused variables. So so you can't just have this. What you have to do, so here's a little bit of magic. When I press save, it's going to actually format the document for me. But the formatter actually does this. So what happens here is that it will auto discard if you're not using this, and you have to explicitly say I'm not using this variable, right? If you're like but at the end of the day, you should not have any not used variables, right? So you should always remove these. One thing I didn't mention is that so okay, so that's the basics, but the problem is that this thing is wait, let me actually re-add this. This thing is actually a type of comptime int. So because this is resolved at compile time, the type is not an int, it's a comptime int, which is a special case. So it's literally like in C when you define a number, you say hashtag define a something, right? So it's like a comptime resolve. So this number can be anything. Oops, sorry, not this, but it can be any length, and it will automatically, when we define a type. So in Zig you define a type with a colon and then a type. So integers are I and then the size of it. So I32, integer of 32 bits. So if you make oops, sorry, I wanted to say this. Let's say, let's remove that. So it's actually going to put this this number into an I32. And one more thing also that I didn't mention is that we don't have compile errors right now. Another thing I didn't mention is that this thing that you can see errors in line, it's very, very useful, and that's actually another extension which is called error lens. So absolutely this one, right? It's not the virus. Yeah, it's this one. So if you install that one, you will have them errors in line in VS Code. Okay. So yes, if you what did I want to say? Yes, there's one more thing, because you will not get compile errors. You will get so for example, if I try to add a number to a string, right? Something like this. Yeah, now it says pointless discard because we're actually using it. So so yeah, but C is not used, so it has auto fixed as well. This is also like a contentious topic. Like, should it behave like this? Like, okay, you're not using a variable, but then the formatter auto fixes it for you. But actually, when you go to some code base online, you're absolutely sure that it doesn't have any of these, because like they're explicitly in the language. Because at the end of the time, you're gonna clean up everything, and you're gonna make sure that there's not gonna be any unused variables. Okay, so yeah, we don't have a compile error here, because this should be a compile error. This is a string literal. So to add compile errors, there is actually a trick, which you can make another step. Well, I have to remember now how it's done. Wait, I have it in this build, I think. There's a check step. No, this is not it. Okay, I'm gonna look for it. Zig compile. No, wait. Let me look into some other project. Amazing. Better ZLS. Yes, this is it. Okay, I'm just gonna copy it from here. Not wrong. Better ZLS. Yes. So basically, you have this check step that you can add into your build, and now what it happens is that you add a check step which ZLS can pick up. So if you call this step check, you can actually put it in the settings of your ZLS, which I can't remember where it is. Preferences, settings. Open the JSON. Yeah, somewhere at the bottom. You can set like, okay, build and save step check. And so what is going to happen now is that it will actually, when you save it, it will build in the background, and it's going to show you the errors. So there it is. We have compile time errors now. Type i32 cannot represent integer. So yeah, this is actually a huge number for i32. This is something that Zig also does. So it's very explicit about casting numbers. So if you can cast a narrow type into a wide type, but you cannot cast a narrow type to a wide type. So that means that you can cast a i8 into like i32 like this. And no, okay, type i8 cannot represent integer. Okay, well, yeah, let's remove this one. let's use something else. There it is. Okay. So, oh yeah, I didn't zoom in. Yeah, but if you have an i32 and you want to cast it into an i8, then, oh, well, here's the thing. This can actually fit in an i8, but this can't. So there it is. Type i8 cannot represent integer value. And the thing is that the reason why we have compile errors is because this is compile time resolved. So yeah. Anyway, but you can explicitly cast things if you're absolutely sure with int cast like this. So it will try to cast it. Yeah, cannot represent. Okay. Yeah, oh, this is because it's compile time. If it was not compile time, then it would work. But anyway.
If you set it as var.
Yeah, let's try.
No. A b set as var.
But the thing is that I'm not. Yeah, I'm never mutating, so that's also not allowed in
Should mutate it somehow.
Yeah. I mean, you can just say b equals something else, right? And let's see. Local variable is never mutated.
No, this one could be const.
Yeah, this one could be const, right?
Yeah, that's fine.
There you go. So you have to explicitly cast it into an int. Yeah. Well, actually, this probably I would need to build, because then we can see if we have an error or not. I wonder now. Oh, it's okay. Oh, there it is. Ah, it has found it. Integer cast truncated bits. So yes, it will actually detect that it is truncating bits, and there is a way to int cast with truncation, trunc. I guess that's the one. I'm not sure exactly. Do you know? Expected vector of floats or float type. Oh, what? Oh, maybe that's for floats. Rounds the given to an integer. Ah, okay. No, trunc is not. Okay. Well, whatever. We're gonna get stuck in this forever at the basics. So, but yeah, what you can see here is like Zig is very explicit at what you can cast into what, and it will actually not allow you to shoot yourself in the foot so easily, like by you can if you have an unsigned value, like it is a U32, you cannot put a a negative number into it. Let's actually see, and it's okay, unused, but the compiler says cannot represent integer value -1. So it's actually gonna panic on all of these things. And one of the also cool things about integers is that if we have a U32, okay, and what will happen now? Is it gonna overflow? Integer overflow. So it actually detected an integer overflow, right? You cannot use like you cannot add or subtract a number over, like it will detect that, because the U32 an unsigned integer cannot store negative numbers. But here's the thing that is like crucial for Zig. Like if you want to shoot yourself in the foot, you can, but you have to do it explicitly. So there is actually an operator which is -% equals, and this one is actually like allow overflow operator, right? So now if we try to do it, it is actually going to work, right? Oh yeah, yeah, there it is. It has compiled, but within log, for example. So I can just say well, a equals, and then you can say a. Yeah, let's see. It should be the 2 billion or whatever, or is it double, or is it 4 billion? Yeah, it is 4 billion. Yeah, because the maximum of signed is 2 billion. Okay.
Do something like U10.
Here's the thing. Yes, you're ruining my surprise. Okay, so yeah, let me go back. What am I doing? Okay, I'm lost. Okay, let's go back to the talk thing. Yes, integers. I talked about overflow. I talked floats. There. Oh yeah. Let's not talk about floats yet. But here's the thing. Zig actually has arbitrary width of ints. So what you can do is you can actually have an U31 or a U30 or a U3 if you want, right? And it's actually going to be like again, it will detect if you're trying to put a U3 number. What is the U3? I don't know, 4, right? That's the top. If you try to put, there it is, type U2 cannot represent integer value 4. So it detects all the casts. And why is this important? We're going to talk a little bit later.
And does it have long arithmetic?
Sorry?
Does it have long arithmetic? Like,
Arbitrary position. Arbitrary
Floats.
no, not really floats, but long arithmetic is like about its integer type, which is like exact. Floats are not exact.
Like integers versus arbitrary large.
Yes.
I mean, it will go up to, I don't know, like if you want to make something really big, you mean?
No.
Like 1,000.
If I want to store like unbounded integers, does it have?
Unbounded.
Yeah.
I don't know at compile time what size it will be.
Yeah. It needs to know what size of it is it on compile time. So.
And what about signed values?
Signed values? Yeah, I mean you can also do it with signed values. So, I wonder what is this. What is I2 then? If it has 2 bits, it can be like up to 2, right? But if it's signed, then it's like -1, and I don't know. Let's see. Oh, there was something. Oh no, that was just unexpected. It's now failing on the end. Let's see. Type I2 cannot represent integer value 2, but it can represent 1, right? Yes. And -1?
-2.
-2, -1, 0, 1.
Oh. So -2 you can also yeah.
Because, like,
for values, yeah.
Opposites, but,
Nice. Okay. Floats are not really interesting because there's just F16, 32, 64, and there's 128 as well. So there's no, it's floats. Okay, so when it comes to pointers, this is where some people are going to be completely lost. But basically, you can grab a pointer to anything. If I say, I don't know, b pointer, just grab it with an ampersand, and there it is. This is a pointer now to the b, and you can then change a const value, right? Oh, yeah. Let's not make it the I2 because cannot assign to a constant. Yeah. Oh, right. No, this is actually a pointer. So you have to dereference pointers. And the way you dereference is that, right? In C you write it like this. In Zig you actually write dot star. That's how it does. But you cannot assign to a constant again because the value that it is pointing to is actually const, right? So so this would need to be a var. And there it is. Now there's no errors anymore. Okay, so basically that is the basics of pointers, but we will come back later. Oh yeah, pointers cannot be null. That is another thing. They always have to point into something. But we're gonna talk a bit later about optional pointers because that's a thing that can happen. But that's another type. Okay. When it comes to arrays, we have like so basically you say you can define arrays as for example 3 U32s, and I can say 0, 1, 2, right? Again, unused. And yeah, so basically this is a inline array. It's similar to C. Actually, it is more similar to like C++ std array because it actually in the type is the number, is the size. So and you can actually get the len, and you as you can see at compile time we know that the size of it is 3. And one more thing is that we can also write if we are initializing the array like this, we can also just put an underscore, and that is going to like be like, okay, it's 3 because we have written three numbers. So now we can add, and we don't have to. It's going to infer the number. Okay.
Does it statically knows that, or it's a fed pointer like?
No, it statically knows it. So this is just the value. So this is like, it's like in the stack. It's going to be 5 integers next to each other, right? It's a value. Yeah, it's on the stack. It's not. So yeah, so it's very similar to std array in C++. Okay, and now it has slices, which are fed pointers basically. So you can and the coolest thing is that they're actually built into the language, right? So I can get a slice to an array by just doing this. Actually, but this is actually, oh yeah, I have to, let's make it var to make it yeah, actually if you do like a pointer of array, this is actually not a slice, this is a pointer to an array. So it's like a pointer to this type, right? So it's a and this pointer still knows, as you can see here. This is the pointer to U32 to an array of U32s. And yeah, for some reason ZLS doesn't know what's the size of it, but actually the compiler knows. So and the thing is that if you want to get a slice, you have to cast it explicitly into like a slice of U32. So when you put brackets next to each other like this without a number, that is actually a slice. So this now is a pointer that also knows the size. And what we can do with it is that, yeah, you can use it as an array, right? Well, yeah, I didn't say that. You can, of course, you can just index it like this and change the value. But I can now also index a slice. Let's see if, yeah, this actually works. So you do dereference a slice as well. And the cool thing is that you can pass it around as a slice, because at runtime you might not know what the size of it is. So it has built-in slices.
Are there immutable slices?
I mean, you can make it immutable. I mean, a const slice is immutable.
But it's mutable. You're mutating the second.
Oh, well, then the array needs to be const.
Well, what if the array is not const, but I wanna take a view like an immutable slice to a mutable array and pass it into a function, then not
Immutable slice into a mutable array.
So you have a mutable array, but I want to have a slice that is read-only. Can you write that?
Aha. Huh. That is a good. I don't think that's possible actually. So, oh wait, maybe it's possible if can you actually cast it into a const U38? Yes, you can, right? Cannot assign to a constant. There it is. So we can change the. Okay, there it is. Yeah, I forgot about this because the string literal type is actually a slice of const U8s.
Yeah.
But you know we're gonna but yeah, you can make it. So this is a const slice. You cannot change it as like you cannot change it to a different slice, but you cannot also change its data. Okay, cool. Yeah, there we go. Okay, strings. Yes, and I say what strings? I just actually mentioned strings because if you have a string of something, right? Oh, the Decentrala. Right? What is the type of a string? What? So it's actually this is a pointer to an array. And what is this 0? Does anybody know what is the 0? This
0-based string.
Yeah, it is null terminated. So actually in Zig, it is known at compile time whether your slice or array is null terminated or not. Well, they call it sentinel-terminated because you can actually use anything for termination. You might use some other symbol. But this is what is like also cool about because now
you can technically have two types of strings depending on different termination, which
Yeah.
can overlay each other and use that logic.
Yeah.
For writing viruses, actually.
There you go. Yes. If hello stream, it's good for writing viruses. Not said by me, it's said by the audience. Okay. Okay.
You know there are strings that are not null terminated, like STD string in C++?
So this is yes, you can if you do an array of characters, basically. That's what you can do, right?
Are these ASCII symbols? What about Unicode?
So this is like a U8 type, right? Unicode, yes, there is actually in standard library there is Unicode, but I can't. Yeah, there it is. There you have special types for Unicode. So if you operate on Unicode, you can do Unicode as well.
But if you put Unicode in literal,
I'm not sure. There is actually a way. There is something. Yeah, let's. I don't know. Let's see. Whoa! Let's see what happens now. Oops. Oh yes, and of course for strings, you should put s. But let's see what happens. Oh yeah, can I? Yeah, let's actually remove. Let's remove the whole thing. Yeah, let's remove all your code bases that belong to us as well. It's too scary. Aha! It has actually written like U8, right? Because I mean the type of it is. But I think it is possible. Yeah, it is possible. I've seen code where they actually put like string literals with like emojis, and then you cast it into the STD Unicode stuff. So it's possible to somehow write it directly in the code. Okay, so yes, basically I say what strings because Zig doesn't have strings. I mean, it does have Unicode stuff, but the string is just an array of U8s, right? But you have a lot of things in the STD like mem, and you can actually do a lot of things with so you basically don't need to even wrap it into a string class. Well, class. It doesn't really have classes because, for example, you have a concat in the library that will take two strings, two slices to a string, or multiple. Well, yeah, you can do anything, and you have to provide the type because it's compile time, and you have to provide an allocator. I'm going to talk about it later. But yeah, basically the standard library has everything you need for manipulating with strings. So it's, wrapping them into like some kind of string class is not even necessary. Okay, yeah, structs. So,
One question.
yeah?
Is these like concurrent and other stuff like safe?
Yes.
C is not safe.
I mean, it depends how safe you mean. Like,
I mean, in C you never use it like you use like concat with like predefined length because it can be like buffer overflow or something.
yeah, well, it is because C standard library operates on all terminated strings, right? But as the Zig mem stuff operates on slices.
So it's like it's guaranteed by compiler.
Yeah, so you pass in a length as well, right? So then you cannot have buffer overflows because, yeah. But yeah, I don't know the compiler details that much. Okay. So structs, you basically define them like this. You say, I don't know. I don't know. I don't know struct, and yeah, you also like because structs in a Zig can be anonymous. That is why you're like you define them like this, and then you give them a name. So you can say you create a struct and you give them a name, and they can of course contain values like I32, B, I32, whatever. Yeah, let's do like some kind of vector 2D, that classic So this and struct, of course, it has a known size. It's always on the stack. So when we create a type of I don't know, vec, and we say vector 2D, and yeah, actually you can define it like this. Vector, you can initialize it like this, okay? And let's see what happens now. Ta-da! It says missing struct field X. So actually, in Zig you have to define. Oh yeah, before I say that, this is a neat thing in Zig. If you write it like this, X, comma Y, it's actually gonna format them in line. But if you add a comma at the end, it will actually format them vertically. So and the cool thing is that it actually works in function parameters as well. So you can have like, A, B, C, and then you put a comma, and it will actually sort them vertically. I don't know. Yeah, like this. You can see.
What does it mean, like const vector to D? It means like it's a constant struct, or
No, this is just a type. So you name you create a struct at compile time, and then you give it a name. So this is just like alias to the struct, right? This is just like so we know it's similar.
What if we do var vector? Can we change
You
the
cannot-
struct on the fly?
No, you cannot do that because it's not compile time. Variable of type must be constant. Yeah. So type. So here's the thing about Zig, which I intended to talk about later. But at compile time, you can actually manipulate types in any way. Because type is a type at compile time, but not at runtime. So at runtime, you cannot manipulate types. You can only manipulate them at. So maybe you could do a var if it's a comptime var. I don't know if this is legal. Because you can do comptime variables, which can, it's kind of like const expr in C++. But anyway, no, I don't think this is. But we're going to talk about method programming later. Okay. So yeah, it says here we had error, and it says missing struct x. That is because we in Zig you have to initialize every variable, right? You have to initialize everything. And if I just try this, it's gonna say missing struct field y. So you have to explicitly initialize every member of a struct. However, you can default initialize. So I could say equals 0 here. And what that means is that, yeah, if I don't default initialize something, then it's going to, yeah, if I now remove it, it's going to say like y is missing because it's not, yeah, you have to initialize the uninitialized things. So you can't do that. But there is another thing in Zig, which is like in C, this is default, but in Zig, it's like, no, you want to shoot yourself in the foot. Yeah, you must shoot yourself in the. It's on you, right? So I could have a vector 2D, which is actually undefined. So what that means is like allocate space on the stack, but that thing is going to be gibberish, right? So it's like in C you just create any variable and you don't initialize it, you get. But in Zig it's explicit, so like you explicitly have to undefine it. You have to say, this is not going to be initialized. So yeah, and there is like there's this meme which I was trying to find a GIF of, and I couldn't in C++. Like how many initialization types there is, like this Forrest Gump when the booba is talking about, you know it, where it is like there is this and this and this. When in army, it's stupid to retell the joke in a meme. But it's like it's literally it's saying like 20 different ways to initialize a variable, and in Zig, this is it. I just showed you. Like you can either initialize things on stack like this, like you have to say what it is explicitly, or you default initialize in the struct, and that's it. There's no other kinds of initializations.
But what happens if you like try to access now back value? It has default values.
Let's see what happens. Let's see what happens. And I think that I don't know if this is actually going to work, or I'm gonna let's see. Oh yeah, of course I did initialize. Wait, this is interesting. Oh, maybe this is because we're in debug. Maybe we're in debug. So x is 0. Let's see what happens if I don't initialize it explicitly. This is interesting. Huh, it is 0. Maybe that is because we're in debug.
It could also be garbage because
Yeah.
random memory sometimes is 0. So
Huh.
if you initialize it to 42 or something, maybe you see the difference.
What do you mean by initialize it to?
Default initialize it to 42.
Okay.
Maybe it clears out memory.
Yeah, it does clear out memory. Yes, but this I think is only in
Yeah, in debug.
in debug. Yeah. So if you do a fast, and the safe, because safe is like, yeah, but I'm not gonna try fast now because it's gonna take time to compile. And anyway, so there you go. This is structs. You have fields. Fields are always public. This is like, you know, it doesn't have private protected bullshit. So, but yeah, okay, I'm gonna talk about it later. And the members are rearranged to have a better memory layout, unless they're extern. So extern is like make it compatible with C. That's what it means, you know. And yeah, I didn't talk about structs can also have functions. And here the thing is that if in a function which has a name, if you pass a self, if the first, well not a self, but let's do a vector 2D. If the first parameter is either a pointer to or the vector itself, it's going to be it's actually like a thing that you can call on the vector. So I could say vec.name, right? So yeah, this is where it's like, but it's basically, it's not, you cannot really call it object oriented because it's literally like a namespace function, because it's just the compiler automatically passes the self to the function, right? To this thing to a function, and it's exactly the same as if I would write this. Well, you have to do, of course, call it. Oh no, yeah, there it is. So you can do this or that, and yeah. Okay. So initially, yeah, the default initializer, I talked about that. You can force with undefined, yes, and files. I put here files. Why files? Because this is another cool thing how Zig solves a lot of problems of C. Right, in C you have like, if you include another file, it will literally be copied like on the top of the file. Wherever you wrote, you can actually write it right in the middle of the code. What Zig does, we're looking at this error lens all the time. Let's create a new file and let's call it other.zig. And this other zig, I might have some function that is, I don't know, add two numbers. Let's return 32. Yeah, return 3, whatever, right? Well, okay, or let's have a pi, you know, 314. And yeah, that is going to be comptime float. But anyway, yeah, what you can do is you can just include other, well, like this, other.zig, there it is. And now, here's the thing. When you import, you give it a name, right? And the thing that's what you give it a name here is that other, there's nothing here. Why is there nothing? Because you actually have to make it available, and that is with the pub. So yeah, I say there is no private, but in other files they do hide things until you make them pub. So now .py, you see. So here's the thing. Here's the thing. How does this work? This works because a file is a struct. That's it. That's the magic. So this is also a struct. It's literally the same as if you created the struct, right? I could move this into a separate file, this thing, and make that into like a vector, right? But then I would need to give it a name here, right? I would need to say vector. So a struct, and that is how Zig solves all the C's problems basically with including, because they are automatically namespaced by having to give it a name and calling it with a name, right? So that.
Do you? Okay, so you can have a variable with type other now.
Yes, yeah, you could have.
Like in main function.
Yeah, but wait, other.
Okay.
Right? Yeah, except I didn't. Well, yeah, if you wanted to make it a type, I guess it's better to make it. Huh? Let's see if this works. That's a good question. It should work. Yeah, it compiles. So yes, This is a type.
Can you have like structs within structs?
Of course, yeah, you
You
can.
have a struct there in the file. Right?
Yeah,
Yeah, that's why I'm asking.
yeah, because structs are in files. So yes, to be structs are top. Yeah. Anyway,
Can you import main into other?
that's a good question. I think. Okay. Yeah, let's try to do this. Import main.zig. Yeah, I guess that's allowed. So okay, and then I can main. Yeah, I don't. Yeah. Oh, I have a main. What happens now? Yeah, I'm not calling add anywhere, so this is totally legal, right?
Call it.
Yeah, but I call it in main. Okay, no, not. Yeah, I did make it add,
Okay.
right?
Stream will now stop.
Yeah. No, let's see.
Go.
Oh yeah, I made it into a sorry. Value of type ignored. Yes, we cannot ignore. Another cool thing about Zig, you cannot ignore return values, but you can explicitly discard it, right? So yeah, let's see. What did it do? Error union is ignored. Oh, it is because it's an error. So we have to try. That's another thing that I didn't talk about yet. But because this returns an error, the exclamation mark is an error. So we have to explicitly discard it. Okay. Okay. Here we go. Oh!
Stop it.
Stop it. How do I stop it? Oh, there it is. Control C. Cool. So there you go. Even this is possible in Zig. All right. So what's next? Yes. And another cool thing, we talked about variable sized things, right? We talked about that you can have 23 and I5. Why is it really important? Why is this I5? Well, this is actually going to be, yeah, if I go, let's try to compile error. Let's try to compile error a type, no, let's do a size of. Oh yeah, by the way, I completely forgot to mention, but all built-in functions start with a at symbol. So that is also super cool because you can just say at and see what's up, what's available, right? You can use any of these. Yeah, let's do a size of vec.x, right? And let's see. Yeah, it complains about unreachable code because it's compiler. Expected size, but does it say actually? Wait a minute. Expected type. Oh yeah, of course. I have to get the type of it as well. Comptime int. Wait a minute. Type? Cannot have.
No, it should
Okay,
be.
yeah. Okay. I don't know if this is going to work, or I have to do it at compile time. Yeah. Wait. Expected const. What? Type of. Oh no. Type of turns it into a string, right? Okay. I am. Oh. Maybe I need to do a vector 2D. There's no member X. Okay, I'm getting bogged down here. I just wanted to check the size of it.
Probably need to cast the result of size of to the string or something. Like compile error expects the string maybe.
Let's try it like this. Something. Yeah, but maybe compilers don't work. Size of because of this ZLS compilation. Yeah, let's just do it at log debug. I'm just gonna log size of f. Oh well, here's what I can do actually. I can just log size of i3, right? And I have to. Let's try with compiler. Compiler size of i3. Is it gonna tell me? Are you gonna tell me? No.
You need to convert size
Yeah.
of to the string.
You think so? No. Yeah. Let's just do this for now. But I just want to prove a point here. Okay. So you see that size of I3 is 1, right? And that means that it's 1 byte sized. So even if this is only using 3 bits, it's actually using all the 8 bits. But if you had a packed struct, so if I add packed, then it will actually pack it by bits. So this is going to be first 5 bits is going to be used by X, and then the next one is going to be used by Y. So you can completely like pack tightly in memory, right? All your numbers. And a bool is also going to be a byte in not packed context, but in a packed context, it's a bit. So what you can also do is, like you can have some kind of flags, right? And you can have a I don't know, windowed. This is like for a screen, right? You can have bool. What am I writing? And you can say like true. Okay, minimized. I don't know, whatever, right? A bool. And that's gonna take byte. But if you pack it, it's actually gonna take, single bits, and basically you can use it as flags. So in C you need to do how do you call it, bit arithmetic. In Zig you don't have to use it at all. So you can just create a packed struct of bits, and you can just set it to and you have like named things, and it's very nice. And another thing that you can do is you can take for example, in this packed struct, you can take a pointer to Y, and you might be wondering, how is this possible? Because pointers are always like what? Oh yeah, okay. It cannot have another struct which is not packed. I guess that's what it's trying to say. So let's remove other. But how is this possible to get a Y of a pointer to it? And we can actually change it. I'm not gonna change it now, but you can actually change this value, and it will actually change the correct value. What is actually happening is that at compile time, this pointer is not really a pure pointer. It also has information about which bit it is on. So if I go and I say type of this pointer, actually does it even work if I just hover? No, it doesn't. It doesn't actually. ZLS doesn't show. But if I take a type of pointer, is it gonna work? Let's see. Yeah, there it is. So as you can see here, it's not a normal pointer. It's a pointer with alignment. So it's like a special type that Zig has to allow pointing into bits, which is pretty cool if you need something like. And the thing is that under the hood, when you use those flags, as I did, it's basically doing pointer arithmetic in assembly code, right? So you don't have to ever use. Sorry, I didn't mean point. I meant bit operations, right? So that's pretty cool. Okay, yeah, it has enums. They're very similar. I mean, it's just like C enums, but they're namespaced. And yeah, there's unions. There are bare unions, which can, yeah, very similar to C. Wait. Yeah, you basically can say union, and you give it a name. It's very similar to how it's defined to a struct. my union, whatever, and you can have a type of I32 can hold something, right? And I think that is how you define it, or you say int, and then you have a type of I32. I think, no, maybe it's like this, right? And it can only hold, like a union can only hold, for those people who don't know what a union is, it's basically, in a struct, all the fields, they occupy different spaces, right? If you have two floats, it's one float and then there's the next float. In a union, they're all at the same space, occupy the same space. So whatever you add, if I add a float here, these have exactly the same address. So the address of this int and this float is the same. Whoops. But here's the thing. In Zig, it will actually check which one is used. So, and like C. So you cannot do type punning as you would do in C. For type punning, you need to use explicitly compiler, like one of those pointer cast, I think is. But yeah, I just want to like steam through this. I don't want to show it off. I just want to say that it exists. But the cool thing is that there are also tagged unions which are built into Zig. And so basically, if you have an enum of something, great, and I have an enum that has like I don't know, 1, 2, 3. I can have a union that will take a type and then you get a, and then for 1 you can define something, and then for 2 you can, I think so. Okay, I actually can't remember how it's done. Okay, help and wait, Zig documentation. Yeah, so by the way, the entire Zig documentation is in one page. So if we just look for tagged unions, there it is. So okay, so yeah, you can have an enum and then you can use a enum as a type. So now you can have multiple things as your like enum. I don't know if that makes any sense, but oh, what have I done? What have I done? Responsive design. Yeah, but it's really cool because you can actually use in like with the tagged unions, you can basically use like it's basically polymorphism but on the stack, right? Because you can actually have you can actually put multiple types into a single space, and you just use a tagged union to switch between the different types. And the cool thing is that you can use a switch statement to switch between these types. And the cool thing about in Zig is also that the switch statements are exhaustive, so you cannot miss. You're not allowed to miss not having not handling a case. That's the word I was looking for. Okay.
So the question, so this union thing is what in C++ is called variant?
Yes.
Variant?
Yeah.
Right.
The variant.
Okay.
Yeah, but you have on the index your variants and
Okay. Yeah. Right. I don't think I've ever used variants. Or maybe I did because... No, I did. I did use variants because unions don't support strings. I wanted to have strings inside, but then you have this constructor-destructor things that like, oh, it cannot support strings because of whatever. Because of destructors. Yeah, I guess it doesn't call destructors or something. Yeah. And yeah. Oh, yeah. Okay, one more thing. Oof, there is plenty of stuff to talk about, but let's try to... Yeah, okay. So this is like the important things. In Zig, this is actually exactly what kind of tags onto this thing. Oh, this should be hidden. So Zig has no operator overloads. So the plus is only between numbers. For example, and equals is always a copy. So it's always a shallow copy, right? So you always copy like stack to stack, and you know that like in C++, when you say vector equals another vector, it will actually copy the entire memory, and you don't know that. You have to like read the documentation to figure that out. Like, oh, it actually creates a copy. But no, if you have something like a vector in Zig, which only has pointers to some faraway memory, it will only copy the pointers right inside it. So it's very easy to reason about memory because you know that there's no operator overloads. An indexer only works on arrays, slices, and multi-item pointers, which is like which I already showed, right? You cannot overload a indexer, and at always it gets a pointer to, right? You can cast it to a slice, you can like coerce it to a slice, as it is called in Zig speak, but it will always get to a pointer, right? And I say looking at C++ because that's one of the major problems in C++ that you can override an ampersand, so you have no idea. And then in the modern C++, they added some reference. Address off, right? Stood address off, so that you're absolutely sure that that's actually a pointer you're getting and not something. It's ridiculous. And now you have to, I don't know, change all code bases to use the stood address off. So yeah, in Zig you know that this is just a pointer. And I say, but I'm a game dev, and I really need vector arithmetic because, like, you know, I would love to write plus minus between vectors. Well, don't worry, because Zig has vectors built in, and you can actually create them with like you can just have a vector of you define a length, you say 3 F32s, right? Classic vector 3. So yeah, I don't have to. I just made this for like this talk, but now I know that there's actually a vector 3, and I can say, okay, my vec 3 is this, and you actually have to also initialize it. So you initialize it similarly to arrays, and you can have actually any number of vector size, and if I put, you know, 2 vectors, I have vec1 and vec2, and I don't know, let's change up something, and I can do let's log a vec1 plus vec2. So yes, you can do vector arithmetic between the 2 vectors now, and they're gonna and we have 1E0 because that's the standard float formatting. But you can there's also formatting parameters you can add. Anyway, yes, you can see that you can actually add vectors, and you can also multiply, divide. I don't know. You can, and the best thing about it is this is automatically using SIMD functions. So SIMD is like single instruction, multiple data. There you go. So it is actually going to use most CPUs today have SIMD instructions, which are super efficient. You can, with one instruction, you can calculate multiple numbers if they're in the same memory. And yeah, of course, you can do that in C and C++, but you have to use the intrinsics, which are like super complicated. And in Zig, you don't have to do it because it's built in.
Matrices?
Yeah?
Can you make a matrix?
Like a 2D, I'm not sure. I don't know. Vector of vectors.
Yeah, but technically they can be not like.
Can you do a vector of vectors?
Where
Yeah, you can format it linearly, but
Let's see. Okay, let's do a 3x3. Okay, let me remove this. Expected integer, float, bool, or pointer to the vector element type found. Yes, so it only accepts integers, float, bools, and pointers, unfortunately. What a disappointment. Maybe they will add it, I don't know.
But we can have a pointer to another vector.
Yeah, you can have a pointer to another vector.
Pointer to another vector in the vector. Can you do it or not?
like
You had something in the error, like
This is this talk is gonna take forever, but it's challenging. So vec 0. Let's do actually let's go back and let's just turn this.
Do we have like a type of a pointer to a vector?
Yeah, it would need to be a. What is it? It's a pointer to a vector of 3f32s, and let's have a vector like this, and then, well, can I actually reference the same one? That would be interesting. Is this valid? Expected type vector found const vector. It can't be
you can
what?
just change the
Yeah,
same
because
one.
you have const vector.
You just apply const in this type. Yeah.
In this what? In this type.
And
Incompatible. Okay, yeah, of course I can't add them, but does it compile?
yeah.
I guess it does compile, yeah. But yeah, I wonder what happens if these are pointers to the same vector. Can you actually mutate it? Like, well, yeah, can I do, I don't know. Anyway, try at home. Let's but yeah, if it's like a simd vector, I'm thinking about like how is the simd instruction gonna, maybe it doesn't do simd for pointers. I don't know. It's maybe there's somebody, yeah, I'm okay, there's nobody chatting, so okay, let's go with yeah, so functions. We already showed that you have to have a fn in front of it, and the cool thing about Zig functions is that all the parameters are always const. So you know, if you have a function like this, oh wait a minute, where am I? Oh, this is the wrong one. Okay, if I have a fn that did a add, right, and this is a I32 b I32, and we're gonna return I32, and we say return a plus b, for example, right? These are const, so we cannot actually modify them. I cannot set it into something else. Oh, and of course, we don't have any errors because Zig is lazily compiling, so we actually have to use it. I need to say like this, and let's just discard because I don't care. Okay, and there, you cannot assign to a constant because this is actually a const. So you know, in C++, I'm just so used to make everything const, and it's like it's refreshing that in Zig it's always const. And the cool thing is that Zig compiler, I'm not sure if this actually works yet, or is this a planned feature, but basically under the hood, it is going to look into, because it knows that this can't be mutated, right? It's actually going to it's going to for you, it's going to say, is this small enough to be passed as a value, or should I pass it as like a const reference, right? Because in C++, when I do, I spend so much time thinking like, should this be a const reference or should it be just a value? But in Zig, the compiler actually decides that for you, because it's like it's an in, so you don't have to think about that. And if you do want to pass, if you want to change a value, right? What do? Well, you just pass it as a pointer, right? Simple as that, and then you can actually change it here, right? But then you have to actually have a changeable value. Of course, you cannot have. You need to have I32 that is something, and then we say we can pass it as a pointer. Incompatible types. Oh, that of course this is a pointer as well. So there we go. All right. Yeah. One thing is that return type must be known, so you cannot. Oh, yeah, well, this is actually stuff for later for comptime. So let's not talk about it. Yeah. we're now only at control flow. So yeah, let's just steam ahead through it. It has if, while, you know, classic. But here's the thing. A for loop. This is how a for loop looks like. Do I have an array somewhere? I don't have an array. Let's make an array.
Can you for loop a vector?
Well, let's try. Let's try. Vec 2 and value. I guess you can. Oh no, type does not support field access. So no, you can't. That's strange.
Yeah.
I thought.
What do you mean? How do you access it? Wait.
I thought you could.
Fields.
Does not support field.
How to get slice from the vector?
Anyway, let's go with let's just go with an array.
Not really a vector, more of a Cindy vector. That's why you cannot do value.
Yeah, maybe that's the thing. Okay, 1, 2, 3, whatever. A quick array, and okay. So this is how you do it, right? So it's basically like a for in Zig is like it's a for each, like in C#, right? Or a range for in C++. But here's the thing. You write an array first and then the value, and when people see this, they're like, no, you have ruined everything. You have destroyed. Why do I have to write value after it? But you know what? It actually, once you start programming, it totally makes sense because these things are, as I call them, well, I don't know if that's the official, but it's like capture bars. So what it does is that the expression actually creates a variable for you, and it stores it into this variable. So now you can use it. And I say this because there's also other things. You have while loops that can capture optionals. You have ifs that can capture errors. So they can give you errors, or they can give you, or switch statements that can also produce variables for you. So it actually when you start coding, it totally makes sense. It's just a tiny little nuisance at the beginning, and then you fall in love with it. And the cool thing about it is that for loops also can have multi objects. They call it multi-item for loops, I think. So basically, what you can do is I could have a range here, and then pass an index in here. So now I have an index as well, and so it's like in C++ you have now enumerate, std enumerate or something like that, and you can get an index like this. So now you can also get a value like this. But that's not all, because if I had some other array, right? If I had array 2, and I wanted to like copy values from one thing to the other, I could just add the other one as well here. And then I have a value 2, right? So now I want to copy like this into this. I could do that, right? Like this. But here's the thing. Cannot assign to. Yeah, this needs to be a var. Huh? Sorry?
Can you change the value, or is it const?
You cannot. It's always const,
Okay.
but of course you can pass it as a pointer. So if you have a pointer, then you can change it. But then you need to actually pass it as a slice, I think, if I remember correctly. So you have to actually pass values. It will not work if you just try to do like value is 3, right? Okay, I have this unused. Pointer capture of non-pointer type. Yes, so it needs to be a pointer type. So it can be a slice or a pointer to an array. And cannot assign, well, it's because this is not var, right? So here, if I make this, then everything works, except with that we have a bunch of unused variables. So there it is. This is how you change them how you can change values in a for loop. So in C++, you have to add const like in a range 4, and I didn't know this for a long time. So all my entire code base was just like for thing in array, and I didn't know that you can actually make this thing and a const, right? But in Zig it's actually a default, so you cannot make a mistake like this.
So in this case, these two arrays should be the same size, or
Yes, if they're not, you need to make them into a slice. So for example, if I had this as a 4, it's actually a compile error, and it's going to say non-matching for loop lengths. So what you actually need to do is you need to grab a slice, and you can grab a slice like this. You can do ... 3, I think. No, maybe you need a 0 at the beginning. Yeah, okay. So you can make a slice. There it is. It works now. So the arrays need to have equal length. The special case is of course this range, because this one is just going to be the length of the longest array that you pass. So it needs to for loop needs to always know the end, right? If you don't know the end, you can use just a while and just increment your I, you know. Okay, yeah, range, I talked about them. Multi-item, talked about it. Okay, yes, there is one more thing. You can actually inline for loops. So if you just say inline, it's going to unroll the loop. And but this should only be used for optimization, like not in every day, but you can just inline for. You don't have to copy the code multiple times just so that you make sure that the compiler will inline. And one thing is that inline must be used for comp time stuff, because if you have something that decides on compile time, it needs to unroll the loop at compile time. Okay, so another cool. Oh, did I forget to write something? No, I didn't actually forget to write something, because these are errors and optionals. So if you put an if you put like exclamation mark in front of the type, it's an error. If you put a question mark, it's an optional. And so the errors, basically, they are, yeah, they need to use an error item. Zig doesn't have exceptions. Instead, what it does have is that it has errors. And you can see here we are already using an error here with the void. So what that means is that the any error we have here, it's going to be read by the compiler. So for example, classic example, we can divide two numbers. Let's do an F32 here, and return, and then we can return an F32, and then we say, okay, return A divided by B, right? But what if the B is 0, right? So what in Zig, we can handle this issue by having an error. So we can actually return an error, but we have to specify a type. So the errors are actually similar to enums. So I'm going to call this a type divide error, for example, and that's going to be some error type. And I'm going to say that one is like division error. So it's basically an enum, right? And then what I can do is, instead of returning this, I'm going to say if B is 0, return divide error, division error, right? And else, well, I can have else or not. Of course, it needs to have a parenthesis. There it is. So if it is a 0, it's going to return an error. And then in my code, let's clean everything up. Fresh start. When I call a divide with a 3 and a 3, right? What we're going to have here is result. And let's do a debug of result. And here's the thing. Let's see what happens. Let's see what happens if we just call it. There's a problem. The problem is that you cannot format an error, and it's like, why? Because the result is actually a type of it's an error and F32. So it's like either an F32 or an error. And what we need to do is we actually have to call try. And what this does is basically like, if this try means if it errors, throw an error and like but also propagate it through all the functions. So because we have main here, you have to propagate it. Yeah, if there was another function, it would also have to return an error. So it's like, yeah. So now we can have a result, and there it is. It's 1E0. Nice. But if we put now a 0, right? It's going to throw an error, and it's going to say at runtime, right? This is a runtime error, and it's going to say, caught an error, division error, division error. There it is. Okay. Yes. So here's the thing: you can also handle errors in different ways, right? You can quickly do a catch at the end, just not with a try, and you can say, well, catch 0. So if there is an error, so that basically means you don't have to handle the error, you don't have to propagate the error, you can just catch the error there, and now it's 0, right? Because we have a divide.
Why is it formats output as a float when the numbers are int?
It's a float.
Sorry.
Yeah.
Switch on the error type.
Yes, and here's the thing: you can also switch on the error type. So I could have a well, I'm not exactly sure if of the syntax. I think we're not gonna let's do a divide here, and let's do a 0, and then I think you can switch in the error. Is it like this? I'm not sure. I have to check.
Something like catch switch.
Yeah, catch switch. The catch. Wait, let's see. There is definitely a yeah. There it is. If right, is this handle all error scenarios? Yeah, because this can also be. You can have many errors, of course, many error types. So you need to switch on the right error type and then handle the thing. Okay, and another cool thing is like the way errors work in Zig at compile time. It goes through your entire code base, and any error that you use, it actually turns into a single enum. So it merges all your errors and turns them into a single enum. So it's just a one number, right? And you actually, this is what back in C days you would get a number like error code. But in Zig, you actually get a nice printout. Well, it's just like this DivivisionError. I just noticed that I have a DivivisionError. Okay, but yeah. Anyway, it's just all your errors are gonna become like one enum under the hood, which is like pretty cool to like conserve space if you're like building for embedded or something. But you still want errors. Yeah, and one more thing is that when you compile fast and you don't handle errors, one more thing that you can do, which you shouldn't do, but you can do, is you can catch unreachable. And what this means is just like crash, because in debug mode this is going to be detected, but in fast it's just going to be stripped out. So all the errors and then when we catch unreachable, we don't have to actually return an error, right? We can just have a void here. So yeah, that is what is cool about that. So and then we also have optionals. So basically optionals can be null. That's the idea. You can have a int that is like I32, and it's actually, if you add a question mark, it can be null. So if you in cases where you can or not have a value, right? And the cool bit about, there's nothing special about them except that, for example, you can, if you return it from a function, like this is one way how you can, while loops can actually return, okay, I'm not exactly sure about this, but there's a way to like capture an int. Okay, maybe it needs to be an array. I think it needs to be an array. So like an optional array or something like that. And then it will go through all the ints and yeah, let's call this ints. It will go through all ints, and you can capture my value that is right now. And the value, local variables never mutated. Okay, let's mutate. It's getting really hot here. I can hear the gasps. Okay, so the thing is that while is basically going to loop until the value is null. So so this is how, for example, you can implement iterators. You know, you can just call .neck. You can have a function that is like, because Zig doesn't support overloading, right? So you cannot make iterators like in C++, where you can just magically for through whatever you want. But you could have a next function in something in your struct, and this one like will return a value which you can capture and handle it, and will end when it becomes null. So it's actually like a pretty nice solution to handle this kind of a case. Yeah, so there it is. And yeah, I said that about oh, by the way, the size of an optional int is going to be, well, it needs to have additional space to store the does it exist thing, right? But that's not the case for pointers, because optional pointers can actually be, if I take an int, you know, well, yeah, not an int, but I don't know. You can take a, yeah, whatever. You can take a pointer to something which can be also null. So a nullable pointer can be, we know from C and C++, it's when it's null, it's 0. So it's actually, there's no extra space wasted if you make it optional. But the cool thing about it is that a optional struct is it's clear that this pointer can be null. So so yeah, that's very nice. In Zig, it's like very explicit. Like if you see just a pointer, you know that it has a value. Okay, what's next? What's next? Yeah, so a little bit of pointers, and we are slowly coming to an end. I can skip a lot of stuff actually, but like in C, you can, a pointer is everything. It can be dereferenced as like a pointer. You can it can be indexed. You can also add to it with the pointer arithmetic and dereference it. It can be null, as we have seen in Zig. You have to explicitly make it an optional, and you don't know if it points into a null terminated string or not. We already talked about this actually. So in Zig, all of these pointers are actually special types, so to disambiguate, there's actually special types for everything. So we have already seen single item pointers, as they're called, which is just normal star type. You have slices, we have already mentioned, fat pointers, right? They have a pointer to memory location and a length, and the bounds are known, right? They're always known. And then you have multi-item pointers, which are basically pointers which you can index, but they're unbounded. And the reason why in Zig code you really wouldn't use them, but you would use them when operating with C code, or maybe you would use them, I don't know if there is any case where you need to. And of course you have sentinel-terminated arrays, which or slices. Well, in this case it's a slice because it doesn't have a number here. If it had a number here, it would be an array, which tells you whether it has it's null-terminated or not. And then of course you have everything above but nullable. There's any opaque, which is basically like void star in C. So it's like a typeless pointer. It's just a pointer. And it does have C pointers that can do everything that C does, but it's only really should be used when operating with C code, right? So you shouldn't ever use them in Z code. And of course, as we talked previously with bit pointers, they can also hold like alignment information. And why do this? Well, because intent is much clearer, right? You can, as a programmer, you know exactly like what this pointer should be used for. You're not you're not completely, you don't have to like, it's not completely vague, and you have to go through like read documentation to figure out what the C pointers are for. And unlike, like C++ has references, but it's like they're kind of like pretending to be pointers, and they cannot be null, they cannot be changed, but like Zig already has them as like normal pointers. Okay, so but one of the biggest features of Zig, which we didn't talk about at all, is comptime, and that is basically its metaprogramming. And at Zig, there's no macros, there's no templates, there's no const expr. You can call any function at compile time. So any function that you write, you can also call it at compile time. This is like what I really hate about C++ is that it has all these, like, it's like one language, but actually it's 6 languages. It's it's like you have you have the normal C++, you have macros, defines everything. You have templates that have completely different syntax. You have const expr. Okay, const expr is like C++, but not really. There's so many limitations of const expr. And then you have the const eval, and I don't know. And now I've actually seen, a few days ago, I've seen a video about the new reflection in C++, and it's a new language.
Yeah.
Why? Like, it's completely different than everything else. And plus, you need to have a build system, right? That is CMake or something. And then you have also, I don't know, whatever, right? You could have additional things on top. And in Zig, it's all Zig. It's just like you do everything in Zig. You make a build system in Zig. You write your metaprogram in Zig. That is the coolest thing. And not just that, but in Zig, types are types at compile time. So what you can do is you can manipulate types completely at compile time. You can. So this is how you can actually create generic types. Although in Zig there's no concept of generics, but because a type is a type, you can actually create them at runtime. So let's actually make one. We can have a function that, let's recreate the optional type. So what is an optional type, right? It has a type and it has some kind of a bool that says is it alive or not. So in Zig, what we can do is we can create a comptime function. So we can say, we can call it optional. Do I have optional already? Yes, I do. Oh, wait, this is not the right thing. This is a wrong, okay. This is actually the one. So if I have what did I want? A function, right? That is called an optional. And because this is going to be a type, that is why I call it with a capital O, right? But generally, you would call everything with a small letter at first. Pascal case, that's the considered norm. And what we're gonna do is we're gonna pass in a comptime type. We pass in a comptime type that is a type, right? But I need to call it T or something. Yeah. And then we're going to return a type from a function, right? And now we can have some kind of a, and what we do is, because this is a function, of course, what we can do is we can return a struct. Right? Oh, wait. Struct. Return a struct. And we can say, and now we basically create a struct. I'm going to say value is type T, and I have exists is bool, right? Something like that. And that's basically it. And now we have created generic type. So now I can actually create a var of optional that is, let's call it opt, because we might have, okay. And now I just pass it a type, right? So I say I want an optional number, and that is it. And then, because of course, this is now a type, so we have to initialize it. And there it is. Even ZLS knows how to do comptime, so we have to assign it to something, right? Does it exist? value. We have already done this. And wait, does it actually know? Yeah, even ZLS knows that this is an I32 because it has created a type at runtime, right? At compile time. So that is how you can create generic like structs or anything in Zig by just passing in a type. So that is pretty cool. That is pretty cool. Can be used to, yeah, example optional. I already did this. But it actually has full static reflection, so we can actually inspect types at compile time as well. And this is where I really fell in love with Zig when I saw this, that there is like this gist that is like, okay, it creates a struct, and then it's inlines 4. It goes through fields. Can you see? No. Okay. It just like walks through fields, right? Of type of X, and then outputs name of fields, right? Like doing this in C++, impossible, basically.
Just wait for 10 years.
Yeah. Well, everything will be in 10 years. It's coming with two more or 3 more languages later, added to C++. And basically, yeah. So yeah, one thing that I had to implement in C++ is like a config. Yeah, I have to save a config file in my game, and you have these like parameters that I need to copy into a config file. But I also want to have named parameters, and for everything I add, I need to add like a new like save, serialize, deserialize, right? Every new thing. In Zig, I wouldn't have to do anything because I can just take a struct and a config struct. I can just walk through all the files and put it into a file, and just with the field names, with the same field names. That's it. And when I saw this, I was like, I'm gonna do my engine in Zig in the future. Okay, intermezzo. This was like supposed to be the middle, but it's not really. So, oh yeah, we didn't talk about memory management at all. Oh my god. I don't know if I should like split this into like 2 talks. Okay, but I mean, there's not a package manager. Oh, actually, this is the end. Okay, no, let's. Okay, 10 more minutes. Okay, is it okay? We're gonna. Okay, so like, just a review of like memory management in languages. Right, we have manual memory management in C. You have malloc and free. You have to make sure that everything you malloc, you have to free, and it's very easy to lose account of that when you start building a big program. In C++, you have RAII, which is like you have you're supposed to like create stuff in constructors and then dispose stuff in destructors. I actually have an example here, which I was like, I'm gonna compile all these things. But there's no time for that. So yeah, basically in C++, if you have like a something, right, some class, and you can like allocate something, and then you deallocate. Well, this is like a combination of C and C++, which is terrible. But this is just a demonstration, right? You in the constructor you allocate some memory. In the destructor you deallocate, and then when the user calls this class, they only see this, right? And what this is like, it creates the memory and it disposes the memory right at the end of the scope. So yeah, here's the thing. It's like you have absolutely no idea what's happening inside here unless you like read the documentation and everything, right? So I could have like allocated million bytes or whatever, right? And I could have run out of memory, and then like, okay, but then what in C++ if I do this? What's gonna happen now? Is it gonna like allocate? Is it gonna create stuff before the main? I guess. I don't know, but you have all these like rules. And what if I have a vector of my class, right? And what if I just like push back a new thing into a vector, right? It's gonna like create a temporary copy, and it's gonna allocate and deallocate and do, and then you have to, and then somebody's gonna tell you like, well, that's because you need to use emplace back, and you have to know all these things, right? so to not have these copies. And as we said in Zig, like a copy is just a stack copy. Like there's no, you cannot overload a copy. There's no like, and if I want to handle this case in C++, I would need to have like a copy constructor, or you have 10 different kinds of constructors that are like, and just having to understand all this is like, oh my god, it's a horror. And then you have to handle all these cases. In Zig, there's no such thing, right? And there's no RAII. Yeah, of course, let's say that other languages have a garbage collector, like Java, C#. Actually, most languages, I guess, use today. And then, of course, you have memory management, like in Rust, which is like compile time resolved. They have a borrow checker, so it passes through your code and figures out like, oh, this is where I need to dispose this memory. And so it's like automatic, but it's you waste compilation speed also. But in Zig, you have manual, but there is defer. So what defer does is that it's a keyword that will postpone something to the end of the scope. So you have like if you have whatever you call, let's do actually like a print. If I do this will happen at, oh, this is not mine, right? This is the one. Okay, let's do this. So we have this happens first, and this happens at the end. And shouldn't it be other way around? Well, if I use a defer keyword, then what it does is that it actually postpones this to the end of the scope. So when it exits the scope, it will run this script. So well, this script with this this line. So if I run it, you will be able to see that this happens first, and then this happens at the end. So this is how you can actually implement kind of RAII, and there's a lot of things that actually use it. For example, you can have like it's a convention to call your init function and your dinit function, dinit, right? What does it say here? What's the problem? Oh, it's because it's in a function. Where's my struct? Vector 3D, yes, there it is. So you have a init and a dinit, and a dinit should never throw an error. Well, hopefully. And so basically what you do is when you create your vector 2D, let's do a var vec, and we're just gonna, yeah, let's do it like this. Is undefined. And then what I can do is I can init and then defer dinit, right? So this is like, okay, at the end of the scope, it will actually defer this execution. And oh, whoops, this should be the init. Okay, there you go. So yeah, and then in the init you can, for example, pass it an allocator or something. Okay, so okay, the last thing to talk about.
Can you defer like one level higher?
No, it's always in the scope. But I guess you can just pass some. I mean, you mean if you have a scope in here?
Function in
yeah, this will.
loop in if statement, then will it like defer to the end of the if statement?
Yeah.
I needed to.
It will.
End of the function.
Yeah, like this defer will be at the end of the scope, right? And if I have a defer inside here, it's gonna be at the end of the scope, right? So it's always at the end of the scope. You would need to like have some value that is outside of the scope and then pass it in to handle it or something.
Can you forget to defer?
Of course, but let's talk about forgetting things. Let's talk about forgetting things, because Zig. So this is why Zig is a little bit more complicated than C, because C has malloc and free. But Zig actually, the standard library at least, it has allocators. So an allocator is just like an interface that allocates memory on the heap, right? Dynamic memory. And there's a bunch of allocators. I'm not going to go through them. But let's try to use a general purpose allocator. And I actually have a snippet here to create one. So here is an example of what is happening here, right? It will create a general purpose allocator, and this actually here is an anonymous. It's like an option struct, so you can actually have many options for mutexes if you're doing parallel stuff and safety, and you can configure it in whatever. And this is also a comptime. So when you configure it, it's gonna create a type for you, right? So anyway, so you have a GPA, right? And then we grab an allocator, and what this does, GPA.allocator, is that it will return you an interface. So an interface is just like a constant, right? It's a pointer to the v table basically. So here is, yeah, as you can see, I'm deinitializing this. But I grab an allocator. So what I can do now in Zig, for example, if you want to have a resizable list, this is the last thing we're going to do. A resizable array, there is std array list. And in the array list, what you have to do, of course, you have to define it. What type do you want? So you can have an array list of 532s. And then we initialize it. And we initialize it with an allocator. So now we're going to pass an allocator into this array list. And what that means is that you can... so for example, if I have... let's call this a list, right? Then what I can do is I can append an item. I can append a 0. I can append... Let's not append 0, right? Because it's going to be awful. We can append multiple stuff. But here is the thing. Oh, error union is ignored because this actually returns an error because your allocation can fail, right? You don't know if maybe you're using a... So here's the thing. This general purpose allocator, it can grow, but the fixed buffer allocator cannot grow. So if you try to allocate into something that cannot grow or you're out of memory, it will throw an error. So what you have to do is you have to try, right? Or you explicitly handle the error. And yeah, so what we can do here is, yeah, and if I want to like loop through the items, I can do list items because list items is actually a slice. So this will give you a slice, and that is why we can loop through it. And let's do an item and let's log item something, right? Item, there we go. And it gives you back a slice of the list currently working. But here's the thing. Here's the thing. If I build this and I run this, we're gonna have some items there. Let's see. Something has happened. Something has happened. Oh no. Look at that. Wait, where's my last call? Yes, it has outputted the items, right? There it is. 324, 480. But it says error, GPA, memory address leaked. So the general purpose allocator can actually track your allocations and whether you have haven't deallocated. So because here, that was your question. Can you forget? Yes, I forgot that list actually has a dinit function, and I have to defer it until the end. And now the general purpose allocator is going to tell me like everything is fine, hopefully. And there it is. There you go. You have handled all your leaks if you use a general purpose allocator. You can use you can also use like std. You go into heap. You can use a page allocator. A page allocator is literally like a system call, like in C. Like it's just a malloc and then you you could have like a fixed buffer allocator, and a fixed buffer allocator. I actually have snippet for it just to show you, because you can, for example, you can have a buffer on the stack, right, that you can pre-allocate. You can put, you know, you can just say, okay, I have 64 bytes, right, and I'm going to undefine, but I'm going to give this buffer to the fixed buffer allocator, and then I can pass this allocator to my list, right, and now I can add things. But let's increase it. Let's put something more so that we don't get an error. And then basically we have the same thing, except you know, this is how like you can just easily replace your allocators if you don't like. There it is. We have just changed the allocator. So this is how you manipulate memory in Zig. And the cool thing is that, of course, you don't have to do any of this in your own code, but the standard library uses allocators. So everything, absolutely everything that creates memory at runtime will use allocators. So you have to pass allocators everywhere. And this is like super cool because it's very explicit, right? And it's also in the user space, right? The user is the one who decides which allocators to use, and it's not hidden somewhere in some constructor or destructor. And yeah. And that is pretty much it. Tests I have managed. Package manager, yeah, it does have a package manager, which is not centralized. You just give it to GitHub, for example, or a Git link, and it will import a package. Yeah, it's super cool. But anyway, okay, so yeah, the conclusion. This is it. So what are some of the cons of Zig? I mean, the main con is really that, should I hide it? Whatever. It's not 1.0, and that means that it's like some things are changing still. And I don't know when the 1.0 is coming. Nobody knows. But it's coming soon. It's sooner than later. You know, it's like next year or 2 years or something like that. But it's definitely a lot more stable. The code base is a lot more stable than like 3 years ago. But I remember I was like, every 2-3 months I had to like change something somewhere, like in the build script. Yeah, I mean, one other thing is that async, it does have async await, but I think it has, maybe it has been removed from 0.14 because there's a lot of things. One thing is like the Zig people, they really want to make it like very clear and very, there's no magic under the hood happening, right? And so async is kind of, there's a lot of magic happening in async, and they want to make sure that the users are aware of all this magic, and that's so similar to how you're passing allocators. So they want to do something like that in async, right? Where users can have the power of like being completely aware of what's going on in the async space. And yeah, I mean, when you talk about like C++, it's much older and you have much more things. I usually say like C++ is bad because it's old. It's like 30, 40 years old, what? And like, but, and it has all these like tumors that are growing on top of each other, you know, tumors that are like on top of each other, like these like new languages for reflection and stuff. But it's also a good thing they're old because there's so many resources, and both online, what you can, tutorials, but also libraries, like you can find anything, especially for game dev.
But there is also documentation poisoning in terms of a search engine. You can find something which is old, which doesn't work, or
exactly
not the way it's supposed to work.
Yeah, I remember it's like the first thing I tried to do in C++ with the make like a game engine, include some libraries, and I tried to do it on my own, and after a few days I was struggling to understand how to include things, and I asked my friend like, okay, can you help me? Like, how can I include this? And he was like, man, why are you using this library? It's like 20 years old. I'm like, I didn't know. How am I supposed to? I found some answer on Stack Overflow. I didn't look at the time, right? But yeah, when you're looking for C++ stuff on Stack Overflow, you always need to look for those little answers as well, because somebody's gonna say this doesn't work in C++. In C++ 23, there's a new thing that you don't have to use this mess or something like that. Or they have added mess. in C++. Okay, anyway. Yeah, so Zig also doesn't have like vtable inheritance or the dynamic dispatch built in, but just like in C, like you can just build your own. You can create your own in comptime, and there is one which is like, for example, this one, which is on GitHub, like you can, and there is like you can just on comptime you can just create your vtables, and but that's usually one of the things that comes up, like, oh, it doesn't have inheritance, you can't inherit classes, and
It's actually good.
but it's actually good because it's not it's not abusable, because it's like the inheritance is super abusable in especially in OP like C#, Java, and like everything is inheriting from inheriting, and but under the hood you just have like pointers to pointers to pointers to pointers to pointers, and it's like super inefficient. So this is where like they really don't want to add this in the Zig because people are gonna abuse it. But it's like it's not that also Zig also already has polymorphism with tagged unions, as I said. So you can actually do polymorphism on the stack, which is cool as an alternative, which is much more performant. One thing is like it doesn't have lambdas. This is actually my biggest problem, is that this is my like I love lambdas actually in C++. Like lambdas are the only good thing in C++. It's like the lambdas defaults are actually sane. It actually makes sense, and maybe I'm abusing them too much, but but Zig doesn't have lambdas. You have to write everything as a separate function somewhere else. But there is actually a proposal for adding not lambdas, but they call them stack capturing macros, which why call it a macro? I don't know, but it's some kind of a proposal. Well, there you can read about it. I don't know, but it's like the problem they don't want to add lambdas is because lambdas are magic, and you don't want to have magic in Zig. You have to have things explicit. Okay, so yeah, there's a Discord. They have a Zigit because when they left Reddit, they created their own Reddit, which they call it Zigit.
Start your own community to add to this list.
Yeah, well, Decentrala. That's Decentrala/Zig. No, dmz.rs/Zig. That's the community. No. Okay, and I just wanted to share this dude, the builder. He has really amazing. Oh, what is this? It's like, is it the link, or is it? Yeah, it is a link. What?
It's a built-in function.
It's a built-in function. No, but this is actually a to-do file. Like, it actually has like. Yeah, you have like this done, and this is why it's yellow. You can compare.
Does it have higher order functions? Like, does it have function type? Can you pass function?
Yeah. Oh, this is something I didn't. It does have function pointers. Yeah. So, but it's very similar to C.
Does it have to be a pointer, or?
I don't know what you mean by then higher order functions.
Like function taking function.
Function taking, yes. Well, you can make it into a function pointer as a parameter.
Okay.
Right. So you can pass it.
Okay.
You can pass a function into yeah.
The short
Or you
answer
can.
is yes.
Yes. Okay. I'm not familiar with higher order.
It just takes functions.
Okay. But yeah, if you have function pointers, I guess you can. Yeah, I just wanted to mention this guy because he has great tutorials. Everything I've done here in 2 hours, he has done in 100 videos. So, and it's actually pretty good, and he's still making them. So, and yeah, occasionally I also stream making Zig stuff, and this is online. All the communities. Offline, they have software you can love. It's like it's a ZigCon, can you call it like that? And I wanted to go this year. It was in Milan, but then I was broke. So no, I actually went to Berlin for another game dev event. So I was like, linking them would be like too expensive. But yeah, they have like lectures, and you can find all of them on the online. Yeah, and they have. Oh yeah, Mach is engine that is being made in Zig, and it's pretty cool, but it's not yet usable. You can use some parts of it, like the maths library. Yeah, this is one of the coolest things is that when I started streaming my engine development, the guy who is making Mach joined in the stream. And he was like, and I was like, well, I need vectors, I need matrices, how do I get this? And he was like, well, why don't you just include Mach? And I'm like, yeah, but I don't want to include the entire engine. You know, it's like, it's too big. And he's like, yeah, but no, in Zig, you just compile what you use. So you can just pick some function from the, it will download the code, but it will actually just use the functions that I can just load in a vector struct and just use it in my. So that was pretty cool that I can like download the engine but just use stuff and then it compiles into nothing. Yeah, and meetups in Zig. I don't know what was this. Oh yeah, I guess I meant the Discord, because Discord meetups. On Discord they have a meetups channel which has like you can create your own meetups there. And I actually made it for the maybe somebody. Did somebody on Zig Discord saw this? No. Okay. Yeah, because I had like 1 heart, so I don't. Yeah, there's not many people who knew about it, I guess, or used it, who are on the Zig Discord. Yeah. Well, what's the future of Zig? Okay, quickly. There's only 2 things. Yeah, the next version is going to add super fast compile times, which is something that has been in development for a long time, but. What Andrew Kelly realized is like we're gonna solve more bugs if we just can compile faster. So this is priority. We have to do super fast. And what that means is that when we compile Zig right now, what I was doing by compiling Zig, we actually compile the entire standard library, right? There's no caching actually at all. So what you have seen is, I mean, not the entire, but of course only the parts that you use. But there is no caching. So what's going to happen in the future is they're going to have caching of stuff. And one of the things that Andrew wants really to add is keeping the compiled code in memory. Like you don't have, in C++, you at least if you have library, you have to have a file somewhere. Like you put it into a file, and then you have to read this file. Like you have the object files that you need to load, and he wants to really keep that while you're working, it's in the memory, and you can just replace stuff in the memory while it's there, right? And that's gonna add, like, it's gonna be extremely fast. There's actually a video demonstrating that, like, changing a couple of stuff, and you can't even see the compiler running because it's so fast. But yeah, it's coming in 0.14. And the next goal is like getting rid of LLVM, because right now they use it. And with LLVM, the Zig compiler is like 170 megabytes, but without, it's 4.4 megabytes. And they, like, this can mean like you can like embed Zig compiler and anywhere, and stuff like that. Or yeah, of course, that's the point.
But it is not dynamically linked then to C, standard C.
No. It's no. You have to explicitly. No, it does. No, it has its own compiler. So, but in the build, you can actually. Oh shit! I just loaded it. Yeah. Well, it doesn't matter. But no, you have to. If you're using C, if you're including C code that uses the C library, you have to link it explicitly in the build script. So you have to say exit.use C library. So. Otherwise, it's not gonna include it actually. So it's actually self-contained.
Okay, it's very 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 small binary, like for.
Yeah, if you do like a small. Yeah, if you do like especially if you do like a small. I mean, we can try. I don't know.
Well, Turbo Pascal compiler could fit to a 1 megabyte disk.
There you go. So that's the goal to reach. Okay, anyway, is that this? Oh yeah. Is there more? No, there's no. Yeah, that's it. That's just me. And okay, I'm sorry. I'm sorry it took so long. I thought it would be 1 hour, but obviously there's too many things to talk about. So yeah, this is like where does Zig fit in the modern world? That's like, this is one of the main complaints that I heard from people, because like when they hear about Zig, they're like, yeah, but I already have C, and C is cool, and I'm using it for 30 years, and why do I need to use Zig? Or like how you have other stuff like Rust, and you have anything else, C++, you know, like why use Zig? And to me, it's weird that like you have seen the talk. Are you convinced? There is a lot of things that, you know, Zig does a lot better than other languages, and one thing is like, yeah, it's like if you were like a C developer, Zig is just like it's such a little addition to C that you can like learn it so quickly, and then you just lose all the pain points, all the shooting yourself in the foot stuff, and yeah, so like, of course it's great because there's no like to me the most important thing about Zig is like it reduces friction so much, like because you have the build system, you have everything in Zig, you have comptime, you have, you know, this thing where I talked about like C++, like I have to think about architecting the code, and you know, how to do, should I dynamically link, statically linked, should I like you know, should I forward declare stuff or inline things, or I have to constantly think about it. And in Zig you just don't have to think about any of these, you know, do I const pass or const reference and stuff. Anyway, yeah, and yeah, I just mentioned a few. So Tiger Beetle is probably the biggest company that already uses Zig. Yeah, Zig is already used. Like that's the thing. It's like Zig is here and it's here to stay. So you can go, and it's not something that's gonna die because it exists already and it's usable and you can build stuff in it. And Tiger Beetle is like the biggest company that uses it, and they're basically making database stuff, financial transactions, yeah, create it's something that you need to have super optimized, and it says 1,000 times faster because of course it's written in Zig, and you have tight memory control. Of course it doesn't automatically become optimized, but you have very good memory control. And then Bun also, that's something that people have usually heard of, like it's a JavaScript runtime which can replace a drop-in replacement for Node, for example, so you can run it on the server. It's extremely fast and it's entirely written in Zig, and the guy who made it is actually like pretty cool. You can find some talks where he talks about Zig and why he chose it, and yeah. And Uber, yeah, interestingly, the first company that I heard about it is Uber, but they only use it for the build system. So they have like C and C++ code, and they actually just use Z as like their like all-in-one tool chain for building C and C++ code, and then they just, you know.
Actually, a lot of people use it because,
yeah?
For example, we have in Rust world cargo Zig build,
yeah,
which can just replace C where you use C code in Rust. So you don't have to care about setting up all your
yeah.
DLLs, because like in Rust world, if everything is in Rust, you don't care. But if you have to import something from C, you have to care like, oh, it is like lib or OpenSSL, or it's 0MQ or whatever. So Zig does it for you, and you don't have to care. And for all platforms.
There, yeah, that's amazing about Zig. Yeah, there you go. The first time I hear somebody like say, "Oh, we use Zig in real life." Okay, so yeah, that's it. And yeah, there is like a Zig Zen as well, which we can write. So if you call Zig Zen, it will give you this manifest of like what we want Zig to be, right? Communicate intent precisely. Edge cases matter. favor reading code over writing code. I'm not actually sure about that. Only one obvious way to do things. Yes, this is like one of the biggest things, like which I said it in the beginning, but like this is really like in C++, there's so many ways to do so many things, and in Zig there's usually one obvious way, right? There's many ways, of course, but there's one obvious way. Runtime crashes better than bugs, compile time errors better than runtime crashes, incremental improvements, avoid local maximums. I'm not exactly sure what avoid local maximums mean in the context of Zig, at least. Reduce the amount one must remember. Focus on code rather than style. Yeah, this is one of the things that, like, oh yeah, it just has a formatter and it will do automatically, and when you look at Zig code, it looks the same. You don't have to waste energy on reading somebody's like, what? Oh, they put arguments on the next line. It's like in C++, it's a chaos. And some people are probably gonna say like, oh, I hate it, you know, this is, it's like your Zig is like, I feel like I'm in a cage because it doesn't allow me. But that's what actually allows you to be focused on the code and be able to read other people's code. Resource allocations may fail. Resource deallocation must succeed. Memory is a resource. Together we serve the users. And this is like, you know, oh, the users are the important. Yeah, so there we go. And finally, I guess, oh, well, yes. What about other languages happening up? But I don't know. No one can. No, they're all cool. But I think that, like, for example, Jai, does it exist? I don't know. It does exist in beta, but it's been fun. The thing is that the first language that I kind of fell in love with was Jai, when it was like, you know, Jonathan Blow was working on it 10 years ago. But then, huh?
Is it even open
no,
source?
I mean, not yet.
That's the whole point.
It's not, yeah.
Languages which are not open source do not exist because you can't like track even them.
Yeah, exactly. And it's been basically developed by him for the past 10 years or something. And Zig has been open source from almost beginning. Odin is another one that is cool, and it's like a C. It's also like a better C, and but Odin, I feel, is much more streamlined towards like games, and less about general purpose. There's a few things I don't like in Odin, like everything is initialized to 0 automatically. Like you don't have this option to undefine. You do, it's like its allocators are optional, but allocators you have to set it in like a okay, I don't know enough Odin. I have only tried it like one day, but it's like it's a weird thing where like an allocator is actually set as like a program state, where you have to like pick an allocator in some context dot thing, which is really strange. I don't know. There are some strange. Maybe these are all just lies. I don't wanna. I don't know enough about Odin. Let's be clear. But yeah, it's definitely something that you can look into as well. And that's the. Oh yeah, I was also invited to do the same kind of talk in Hamburg, and now I see that, you know, this is way too long, and that I have to cut so many things, and I can't. I'm definitely gonna have to do slides and not to. Yeah, but yeah, well, everybody survived. Congratulations. And yeah, basically you can just go and code in Zig immediately because you have seen enough of the, you know, this is also what is cool about Zig. It's like super complex, super simple. Unlike like Rust, which is like, I don't know, I've coded in Rust for maybe a year, and it's like I discover something new every time, which you and it's just a pain of like fighting with a compiler. But in like Zig, everything is so clear because there's so little things to that can go wrong, right? And yeah, anyway, yeah, that's it, I guess. This is my site. You have all the links to my Twitter. My eyes, yes, yeah, but it's anyway. Yeah, so thank you. If everybody has survived, we can like grab some beer and yeah. Oh yeah, by the way, I mean, I didn't say also, does anybody have questions, but I guess.
No.
Yeah, you had questions during. Okay, so, yeah. Anything in
Actually,
here?
to make it faster, you can pre-record your demos, and also you can probably skip everything which is obvious for C developers, because like it's hard to imagine someone will come for Zig talk and don't know about like allocation, and, like, memory management. You can mention that there's some types of memory management, but you can just totally skip.
Yeah.
Everybody knows that.
Yeah.
Like good talk.
Thank you. Yeah. All right. This is marathon. Oh, ciao. All right. So that ends the stream as well. If anybody's on the stream still, goodbye. We're gonna have some drinks. See ya.